This is Geometry Lesson 3.1. We are going to be looking at arcs and angles. Your big idea says every angle has a measure that is a number in the interval from 0 to 180. The number 180 being half the measure in degrees of a full circle. All right, so we're going to start today looking at arcs, which are a set of points made up of 2 points on a circle and all points in between. So as you take a look at these example circles that we've got, if we have point I and point L on the outside of a circle, everything in between those two that runs along the outside of the circle, all those points, would be considered an arc. And when we name an arc, so if we're going to use IL, we name it similar to a line, and the notation above it looks like this. You put a curve, which makes sense because it represents the side of a circle. So the measure of an arc is actually the measure of the central angle that corresponds to the endpoints. So that sounds a little complicated, but if we take a look over here at this circle, if we have arc EF, which represents these points out here, the measure of that is going to equal the measure of this angle. So one way to notate this is the measure of a little m. The measure of EF is going to be equal to the measure of angle D. Those are going to be equal. This angle in here and the measure of this arc are the same. Now, a circle in total has 360 degrees. So you can see this one right here is considered a 360-degree arc because it goes all the way around the circle. Now, a semicircle would be half of that, an arc that measures 180 degrees exactly. So you can see right here, if the arc goes exactly halfway around the circle, that region it creates in here is half the circle, which you may have heard of as a semicircle before. But this specific arc of 180 degrees, a half circle, is going to be called a semicircle. Now we have two different types of arcs. We've got minor arcs, which are between 0 and 180. And so those are formed in here. Here's your 180. So if I have an arc like this, let's call this CD. Okay, that is a minor arc. And then a major arc is between 180 and 360 degrees. And so if I have this right here, CD, that's a minor arc. If I measured the arc all the way around the outside this way, that would be a major arc. Now if you look, I'm going from C to D again. And so if I just keep calling it arc CD, and there's actually two different arcs, one's very small and one's very big in terms of their measures, I would get confused which one's which if I called them both arc CD. So minor arcs are traditionally named by 2 points. Now sometimes they will name a minor arc with 3 points if it's a very complicated picture and they want you to be very sure of what they're talking about. But major arcs are going to be named by 3 points. So I'm starting at C, I'm passing B, and I'm ending at D. So I would call that C, B, D, like that. Okay, and I still use that arc symbol. So that would be a major arc. Here's 180, half the circle. It's more than 180 degrees, less than 360. That would be considered a major arc. And so if we just, before we move on to angles, if we just take a look at these pictures, if I have a 90-degree arc in here, then I know that this is a 90-degree angle, first of all. Okay, the angle that forms those endpoints of the arc is going to be the same degrees as that. And let's say I didn't know that this was 270. If I know this is 90 right here, the whole thing is 360. So if I do 360 minus 90, I'm going to get 270 degrees. If you add up all of the arcs that complete a circle, it has to come out to 360 degrees. So if I added the 102 and the 30 and the 228, they would all add up to 360. 30 plus 102 plus 228 is going to equal 360 degrees. Okay, so all of the arcs all the way around, it's kind of like a big puzzle pizza. You have to add them all up to 360. Okay, so we started talking about angles. We're going to talk about how we name them and then specific types of angles here as we just get started in chapter 3. So first of all, we know what angles are. We've talked about them. But how do we define them? We're going to use this word union, which we know is the combination of both sets. It's the union of two rays with the same endpoint. So I've got ray DE, I've got ray DF. The union of them, all of this and all of this combined, create that angle. Two important parts of an angle are the sides and the vertex. The sides are actually just the rays, and then the vertex is the intersection of the rays. We've used this word now a lot. So union and intersection coming into play in our definitions. Intersection of the rays, what do the rays share? Point D. So the vertex of this angle right here would be point D. Now, when we name angles, there's a couple different options. So if I'm taking this angle right here, and not talking about the arc, just the angle, I can call this, there's an angle symbol, looks like this. Kind of looks like a less than symbol, but what we do is you make the bottom of this flat, as opposed to a less than symbol kind of looks like this. An angle symbol, the bottom is flat. Just to kind of point that out. But when you name an angle, a lot of times you're going to use three letters. Okay, one from each of the rays and then one on the vertex. And the vertex has to go in the middle. So it doesn't matter which direction you go, but I can call this angle EDF. I can also call this angle FDE. But notice that the D is in the middle of both. So as I work my way around this angle, okay, there's 3 points. 2 of them are on the sides. One's at the vertex. The vertex has to go in the middle. Now, in an uncomplicated picture like this, I can also just name it by its vertex, like I did up here. I can just call this angle D. But if I all of a sudden have more angles that are coming out from here, let's just call this A. If I say angle D now, you don't really know which one I'm talking about. And so now I need to be more specific and use 3 letters to name it. But in a simple picture, you can just name it like that. Sometimes they will actually put a label in here. They'll put like a 1, and you can call that angle 1. Okay, so that's another way you can name it. Okay, so those are the different pieces. That's how you name it. Now let's look at some very specific types of angles. So a central angle, that's what we were looking at here, creates these arcs. It's an angle whose vertex is the center of a circle. So it can't just be anywhere in a circle. Central angle has to be the center, and that's what creates these arcs. A zero angle. This one actually tends to confuse people, especially when we compare it to a straight angle. So we'll take some time to talk about those. A zero angle is 0 degrees. So that's an angle formed with no opening. It forms a ray. So here's your 0 angle. Let's jump down to straight angle. A straight angle is not 0 degrees, it's 180 degrees, and it forms a line. So 0 angle forms rays, straight angle forms lines. Here's a straight angle, here's a 0 angle. You look at those, they look the same, and so that's why there's confusion. Now, how they're named gives away whether this is a straight angle or whether this is a 0 angle. So if we look at this first one, based on how it's named, T is the vertex. So T is the intersection of 2 rays. I have one ray going this way and one ray going this way. And if you think about a circle, that's half a circle, that's 180 degrees. Now, if you look at how this one is named, R is the vertex. Okay, so I have a ray going to Z and I have a ray going to O, and this is where they meet. Okay, so that is now 0 degrees. You could think about it like a mouth, okay, opening and closing. This one is opened all the way. This is the middle. It opens up to 180 degrees. This one is completely closed at 0 degrees, although they look very, very similar. And so we will continue to take a look at those. All right, some other ones that you should be fairly aware of already. An acute angle is between 0 and 90. So we want to be very specific. A lot of people say an acute angle is just small. Okay, it is less than 90 degrees. A right angle is exactly 90 degrees, and you're going to see this symbol right here, this box. If you don't see that symbol, it is not safe to say that this is exactly 90 degrees. And so even if it looks like it's 90 degrees, if it doesn't have the symbol, you are not allowed to assume that it is a right angle. You must have that symbol there. An obtuse angle, okay, you always think of as a big angle. It's between 90 and 180. And then a straight angle is exactly 180 degrees. So your right angle is right in between a straight angle and a 0 angle. And then if it's between a straight angle and a right, it's obtuse. And if it's between a right angle and a 0, it's acute. And there are angles that can be bigger than 180 we'll talk about at some point. But right now we're just focused on those. Now when we measure an angle using a protractor, we will actually physically do that and try that out. But what you do is you put the vertex of the angle right on, there's a certain spot. Most protractors have either a cutout here or they have a dot where you line it up. You put one of the sides on the 0. Now you notice there's a 0 and a 180. There's two ways to read this. But either way, you put that on either side. Vertex here, one of the sides lined up with 0, and then wherever it opens up, it's going to give you a reading. Now, when you look at this protractor, okay, I'm kind of between 70 and 80 or 110 and 100. So I kind of have two choices. So you have to think about what's going on here. Here's your 90. Okay, all of this would be less than, if I had an angle in here, less than 90. So this is greater than 90. The reason there's two is because if I had an angle that was coming this way and I was reading it on the protractor, that would be less than 90. So it'd be hitting at the same spot, but it's facing the other direction. So I have to be smart enough to realize this is an obtuse angle. It's more than 90. So this one specifically would be 105 degrees. It's directly between the 100 and the 110, not the 70 and the 80. All right, if you flip it over, some more key points about angles. Angles form two regions. So we have this angle. One is called the interior and one is called the exterior. To be very specific, the interior of an angle is the part of the angle that's less than 180 degrees. Okay, so that's in here. Think about it as a circle again. Half the circle is 180 degrees. The full circle is 360. And so if I'm measuring this out here, that's going to be more than 180 degrees. And that would be considered the exterior. This part in here, if I complete a circle here on the inside with this being the center of the circle, more than 180, less than 180. Because it's less than half, it's more than half of the circle. Some other key points that we've talked about, convex and non-convex. The interior region of an angle is convex. I can put 2 points anywhere in here, draw a line between them. They will not leave the region. Where the exterior part is non-convex, because I could put a point here and put a point here, and it would leave the exterior part of the region if I connected it. Okay, so we will refer to the interior and the exterior regions created by an angle. Real quick touch on the angle measure postulate. We're not going to focus on it much here, but we will refer back to it later. We've kind of looked at some of these postulates, 4 key points that we want to understand. Letter A, pretty straightforward. The unique measure assumption says that every angle has a unique measure from 0 to 180. So it's just stating an angle can be measured from 0 to 180. Letter B, the unique angle assumption. Okay, so that's referring now to this setup right here. So we're given any ray VB, so we're given this ray, and a number R that's between 0 and 180. So a number R represents an angle measure. The unique angle assumption says that that unique angle, VVA, can be made on each side. So I could make it here or here. Okay, so this is your R degrees. I could also make it on this side. So the unique angle assumption is saying I have this ray. If I'm going to create an angle using that ray, I can do it on either side of that ray. That's how you break that down. That's what that's meaning. Letter C, the straight angle assumption. If VA and VB are opposite rays, so starting at V going this way, starting at V going this way, their measure right there is 180 degrees, half a circle. But the zero angle assumption, like we talked about, you've got V to A and V to B. This is the vertex, okay? And both rays are going this way, so it's closed, and that would be 0 degrees. All right, and we'll refer back to that later in this chapter. Real quick, couple examples, pretty straightforward, nice and easy in this section. Number one, talk about naming angles. In the figure below, give two other names for angle BAM. So BAM. Follow the letters around. Remember, the middle letter is the vertex. So BAM. You notice there's numbers here, and so I can call it angle 1. And then the other way that I can name it is to just go the opposite direction, but the vertex has to stay in the middle. So if I'm referring to this angle in here, created by these two rays, AB and AM, I can make my way around the outside differently. Angle MAB. So it's just the same thing but reversed. Okay, question number 2, talking about degree measurements of arcs and angles here. So this says find the measure of angle ROS. Don't be confused by the notation. Find the measure of angle ROS. ROS. They're talking about this angle in here. It always equals the arc measurement that the endpoints create out here. And so that measure in here is also 32 degrees. But most importantly, it's to understand what's this asking. Find the measure of angle ROS. This says find the measure of arc, RTS. So first of all, I see 3 letters, which means it's a major arc, more than 180 degrees. Okay, so if you're confused on what we're looking at, it's all of this out here. It's the big arc from R past T all the way to S. Now we know if I go all the way around, it's 360. I'm not going all the way around though, because this piece right here is not included, which is 32 degrees. So it's all of 360 except for 32 degrees. So you just take 360 minus 32 degrees, and that comes out to 328 degrees. And the little circle is your degrees symbol. If I put this piece and this piece together, they should add up to 360. Same idea on question number 3. Find the measure of angle AOB. AOB. O is in the middle of the notation, meaning it's the vertex right here. So the measure equals the measure of this arc out here. So it's also 43 degrees in here. So the measure of the arc is 43, and the measure of this angle, central angle, is 43 degrees. And if I want to find the measure of major arc ACB around the outside, it's all of this circle except for the 43 degrees. So I'm going to take 360 minus 43, cut out this part of the pizza. What I'm left with is 317 degrees for arc ACB. Okay, and last, we haven't looked specifically at all of these, except I kind of touched on it with the 90-degree angle, the right angles that I have to have the notation in the picture. There's some things we're allowed to assume when we look at a picture and some things we're not. So examine the figure at the right, line T. Here's line T. So T is not a point. Notice those are lowercase, and these are all capital. Capital represents points on the line. Lowercase is just naming the line. It's line T, line N, line M. Okay, number 1, tell whether you can assume the statement from the figure. Can we assume that point T is on line N? Yes. That's fair. That point is on line N. Just by looking at the picture, I'm allowed to assume that. Number 2, the measure of angle JIK, so this measurement in here, is greater than the measure of angle KIE. So just looking at the picture, I don't have any measurements given to me. Am I allowed to assume that this is bigger than this? No. You cannot assume that. Even if it looks like it, kind of, it's not good enough. Okay, we have to know for sure. Number 3, line M is parallel to line N. It sure looks like it. Okay, but there's no symbols or notation to tell me that they are. It has not been part of a given. Sometimes they tell you part of a statement up here. It's a given statement. N is parallel to M. None of that has been given to us, so I am not allowed to assume that they are parallel even though they look like it. Number 4, JIT. JIT. This space out here looks like 90 degrees, does not have notation. Am I allowed to assume that this is 90? No, you are not. It could be 89.9. Unless it has that symbol. Again, a right angle has to have this symbol, the little square there. I cannot assume it's 90. Can I assume that T is between A and E? Yes, that is fair. AI and E are collinear. Are they all on line N? Yes. There's no confusion there. But what about number 7? J, K, and L. They look like they're on a straight line, but that line is not given to us in the picture. So am I allowed to assume that they are collinear? And the answer there would be no.